Here, we will factor trinomials of the form ax squared plus bx plus c, where a is not equal to 1. So that means that a is something other than 1. It's a non-trivial leading coefficient. So when you're factoring something with a number out front there other than 1, the best method to use is what we call the AC method. So to use the AC method, we are going to find a pair of numbers whose product is AC. So we're going to multiply A and C together, and whose sum is B. So if such a pair exists, then we're going to expand the trinomial into 4 terms and rewrite the middle term, the bx, as the sum or difference using the two numbers that we found in that previous step, that pair of numbers that multiplies to give us AC and adds to give us B. And then we're going to do the factor by grouping method from there. So in a way, the AC method may seem strange at first, but it's actually the exact reverse of the FOIL process. So every time you use the FOIL, first, outer, inner, last, to expand an expression when you're multiplying two binomials together, you get 4 terms that depend on the original coefficients, right? And the AC method is a way of finding those 4 terms and kind of doing the unfoiling there. Okay, so let's walk through some of this to train our brain and how to do this. So the first example here, we're going to factor 4x squared plus 11x plus 6 using the AC method step by step. So we need to find a pair of numbers whose product is, what's A and what's C? 4 and 6. So 4 times 6 is 24. So we need to find a pair of numbers whose product is 24 and whose sum is 11. Okay? And so what do we know about the signs of the numbers before we even try to find the numbers? I know that the last term, the constant term, is positive 6. So both of the numbers either have to be positive or they both have to be negative. The middle term is positive, so because of that, I know that both of the numbers have to be positive. Okay, so we are trying to create a table of factor pairs for positive 24. Okay, and they both have to be positive. So there's 1 and 24, there's 2 and 12, there's 3 and 8, 4 and 6, and then they start to repeat, right? 6 times 4, 8 times 3, etc. Okay, so which two have the needed sum? When we add these up, 1 and 24 is 25, 2 and 12 is 14, 3 and 8 is 11. That's the one we need, right? We needn't go further. Okay, so it's 3 and 8. Those are the ones that we need. Okay, so what are we going to do with that 3 and 8? Okay, so now we're going to rewrite 4x squared plus 11x plus 6 using 4 terms. The two middle terms are going to involve the 3 and the 8. So I'll show you what I mean. So the 4x squared plus 11x plus 6 is equivalent to 4x squared plus 3x plus 8x plus 6. Okay, so you see how I used those two numbers, factoring numbers that I found, the 3 and the 8, and I rewrote the middle term. So instead of having 11x, I have 3x plus 8x. Okay, now once you've done that, now by the way, it doesn't matter whether you have 3x plus 8x or 8x plus 3x. It'll come out the same way. Okay, so I'm going to do the factor by grouping. All right, so in the first grouping of 4x squared plus 3x, what can I factor out there? Well, both of the terms have an x in common, so I'm going to pull that out. So what will remain there? I'll have 4x plus 3, right? So in this last grouping, what else can I pull out? Well, I'm looking at 8 and 6, and I know that 2 is common, right? So I can pull a 2 out, and I'm left with 4x plus 3 when I factor out a 2. Okay, now remember how to do this when we're factoring by grouping. You've got 2 terms here, right? So what's common to both of the terms? Well, 4x plus 3. So we can factor that out. 4x plus 3 is one of our factors. And what's left over? X plus 2. All right. Okay. So this is the AC method, and we have factored this trinomial to the quantity 4x plus 3 times x plus 2. All right. Now, you know me, I always like to check these. So in order to check this, I have to do the foiling back through, right? So 4x plus 3 times x plus 2, and 4x times x is 4x squared. 4x times 2 is positive 8x. 3 times x is 3x. And 3 times 2 is 6, right? First outer, inner, last. And then I can clean up the middle term. Okay, so, and also you can see in this, as we check it, when we did that foiling, we got that expression 4x squared plus 8x plus 3x plus 6, right? Which is the same thing we started with up above. I want to show you something. I'm just going to do a little aside here. I'm not going to do this in every case that we work. I just want to show you what happens. Like if we were to reverse the order of this, 4x squared, we had 3x plus 8x. What if we had 8x plus 3x? That's the way it appeared when we did the foiling, right? So if we grouped them from here, in the first grouping I can pull out a 4x, right? 4x times x is 4x squared, and 4x times 2 gives me 8x, right? And then over here, what can I pull out from 3x plus 6? Well, just 3, right? And then I'm left with x plus 2. Okay, so now what's common to both of the terms? Well, x plus 2, right? And so then I have 4x plus 3 left over. Okay, so and all that happened there when I reversed the order of that middle term, instead of pulling out a 4x plus 3 like I did in my original work, I pulled out an x plus 2, right? So you just pull out the opposite factor, but it'll work either way. I just wanted to show you that. It doesn't matter the order that you present those numbers as you rewrite it into 4 terms. Okay, great. So let's do one where the signs are not necessarily the same. Okay, so here we're going to factor 12y squared plus 5y minus 3 using the AC method, step by step. Okay, so we need to find a pair of numbers whose product is A and C here. A is 12, C is negative 3. 12 times negative 3 is negative 36. So we need a pair of numbers whose product is negative 36 and whose sum is positive 5. Okay, so what do we know about these numbers? Well, if the product is a negative, that means that the two numbers, one of them has to be positive and one of them has to be negative, right? So we're looking to create a table of factor pairs for negative 36, right? And we want them to sum to 5. Okay, so we have negative 1 and 36, negative 2 and 18, negative 3 and 12, negative 4 and 9, and negative 6 and 6. Now, we could also list them the other way, right? 1 and negative 36, 2 and negative 18, 3 and negative 12, 4 and negative 9, and oh, I guess the last one is the same, 6 and negative 6. Okay, but when we add these together, we want a sum of 5. So one of these should give us a sum of positive 5. Negative 1 plus 36 is 35. Negative 2 plus 18 is 16. Negative 3 plus 12 is 9. Negative 4 plus 9, that's positive 5, right? That's the one that we want, so there's no need to go any further. And we could add these up over here, right? But once we found that sum, we know what they're going to be. So we want negative 4 and also 9. So now we're going to rewrite 12y squared plus 5y minus 3 using 4 terms, and then factor it using the factor by grouping. Okay, so with 12y squared, pardon me, plus 5y minus 3, we're going to rewrite the middle term as 12y squared minus 4y plus 9y minus 3. Okay, so a word about this. If one of the numbers is negative and one of them is positive that you're rewriting the middle term with, like that, make sure that you put the negative one first. You can put it second. It's just a little bit more of an algebraic step, because if you have 9y minus 4y, then you have to factor a negative out of the second grouping. Not a terrible thing. You can totally do it. It's just another thing you have to think about. So if you just say, okay, if I have a positive and a negative, just put the negative one first. Because remember, like I said, it doesn't matter the order that you write those two middle terms in. So we can have minus 4y plus 9y or 9y minus 4y. If this way, the minus 4y plus 9y makes our life a little easier, use it. Okay, so now we're out of the first grouping. I've got 12y squared minus 4y. So I can factor out of that 4y, right? And I'm left with 3y minus 1. Right? When you factor 4y out of 4y, you just have 1 remaining. Okay, and in the second grouping, 9y minus 3, I can pull out a 3, right? So then I have 3y minus 1 remaining when I factor a 3 out. Okay, now 3y minus 1 is common to both of those terms, right? So I can pull out a 3y minus 1, and the remaining stuff, 4y plus 3. Okay, so we've factored this trinomial into the quantity 3y minus 1 times the quantity 4y plus 3. Okay, so let's check this. Over on the side here, I've got 3y minus 1 times 4y plus 3. Does that give us the original trinomial when we FOIL it? 3y times 4y is 12y squared. That's our first. Our outer 3y times 3 is 9y. Inner, negative 1 times 4y is minus 4y, and negative 1 times 3 is minus 3. And then I'm just going to clean up the middle terms. So I have 12y squared, 9y minus 4y is 5y, minus 3. Okay, is that what we started with? Indeed. Okay, so let's do another example here. So in this example, we're going to factor 5z squared minus 13z plus 6 using the AC method step by step. So we need to find a pair of numbers whose product is 5 times 6, right? That's a times c. So 5 times 6 is 30. And whose sum is, what's the middle term? Negative 13, right? Coefficient on the z in the middle there. Okay, so we're looking for two numbers that multiply to give us 30 and add to give us negative 13. Okay, so what are the signs on these numbers? So since our last term there is positive and the middle term is negative, we know that they both have to be negative, right? Since a negative times a negative is a positive, right? But a negative minus a negative is also negative. Okay, so we're looking to create a table of factor pairs for positive 30, but both of the numbers have to be negative. Okay, so I've got negative 1 and negative 30, negative 2 and negative 15, negative 3 and negative 10, negative 5 and negative 6, and then they start to repeat, right? Okay, so when we add these up, right, we end up taking a negative and subtracting a number. Negative 1 minus 30, negative 31, negative 2 minus 15 is minus 17, negative 3 minus 10 is negative 13. That's the one we want, right? Yeah. So we can keep going, but once we find the sum that we need, we can stop. Okay, so what two numbers give us that negative 13? Negative 3 and negative 10. Okay, so now I want to take 5z squared minus 13z plus 6, and I want to rewrite this using 4 terms instead of 3. So I'm going to rewrite the middle term using those factoring numbers, and then we're going to do factor by grouping. So to get negative 13z using these two numbers, I'm going to have minus 3z minus 10z plus 6. All right? Okay, now when we go to do the factor by groupings, this is the thing. If both of the numbers are negative, you don't have a choice but having to deal with factoring out that negative. So let's talk about that for a second. So when we do this grouping, because of that negative, if we put a little parentheses around the second two terms and we leave the negative out of it, we have to change the sign on this term, right? Okay, so hopefully that makes sense to you. It's essentially the same thing as factoring out a -1, and we've got to do it anyway with the factor by grouping, but even as we group them, I just changed the sign on that last term. So when you distribute the negative back through, you get minus 10z plus 6. Okay, so now with this grouping, in the first grouping, 5z squared minus 3z, we can pull out a z, right? So we're left with 5z minus 3, right, when we pull a z out. And then in the second grouping, we're going to have, 10z minus 6. I can pull out a 2, right? So I'm going to have minus 2 times the quantity 5z minus 3, right? So again, when we distribute the -2 back through there, we would get minus 10z plus 6, right? Which is what we started with. So careful with that. And now we have a common binomial in both of these terms to pull out, right? 5z minus 3 is common to both of them. So I'm going to factor out 5z minus 3. And what will the leftover be? Z minus 2. Okay, so we've successfully factored this trinomial to 5z minus 3 times the quantity z minus 2. All right, so let's just run through that. Good foiling practice. Again, do you have to check every one of these as you're getting the factoring practice? Certainly not. But it's good to practice it and also to see the relationship between the process we just did and what the foiling process is. Like you're really doing the things in reverse order. So as we foil this, 5z times z is 5z squared. 5z times -2 is minus 10z. -3 times z is minus 3z. And -3 times -2 is positive 6. Okay? So there are the four terms, right, that we started with when we did our factoring by grouping. And if I clean this up, I'm going to have 5z squared minus 13z plus 6. Okay. All right, pretty slick method. So I wanted to run you through just a few step-by-step examples of how to use this AC method. Also worthy of note, this AC method, you can do this method when the leading coefficient is 1, but it's not as necessary because when the leading coefficient is 1, you can just look at C and say, well, what two numbers multiply to give me C and add to give me B? It's not as simple when the leading coefficient isn't 1. So the necessity for this method is greater in this case when the leading coefficient is something other than 1.